Hello guys, I'm Alukosha. Welcome to my math tutorial section. Um, in today's class, we shall be solving the 2020 revised syllabus practice question, Cambridge IGCSE 0580. Guys, this is actually the part 2 of this video, and if you need to you may need to go ahead and watch the part 1 of this very video to get a better understanding on the same, guys. Okay, so this is actually question number 5, so meaning that you may need to go ahead and watch part 1 to gain access to the first 4 question. Okay guys, let's go ahead with the next question. So the derivative of f of x equals to x raised by 3 minus 12x plus 5 is 3x squared minus 12. Find the coordinate of the turning point of the function f of x. Okay, so we have to find the coordinates point. Okay, coordinate of the turning point of the function f of x. Okay, so let me just go ahead and demarcate. Guys, don't forget that this function, we're already given the derivative, which is just like the gradient already. Okay, so and this is the gradient now, so we have to find the coordinate of the turning point of the function. So and now to complete this type of question, what are we going to do, guys? How what am I going to do, guys? Okay, just go ahead and find the coordinates accordingly, because we have to find the coordinate of the turning point. So at turning point, let me just go ahead here. So at turning point, okay, my handwriting. At turning point, okay, so the gradient equals to 0. Okay, or better still, just go ahead and use your dy over the x. You guys, the dy dx. Okay, so at turning point, the gradient equals to 0 or dy dx equals to 0. So we are going to equate this to be 0 because that is the gradient and it's given already. So you need not to start, oh, I don't even know how to differentiate. No. Okay, so minus 12 equals to 0. So we go ahead and find the coordinate of the turning point of coordinate. So we have 3x squared equals to 12. 3x squared equals to 12. So x squared would be that is 12 divided by 3, and that is 4, such that x is square root of 4 plus or minus square root of 4. So now then the coordinate of x there, we're going to have a minus 2 and 2. Okay, so the 2, we have minus 2, x equals 2. I don't know why I'm writing like this. Okay, x equals to minus 2, or x equals to 2. Okay guys, now the next thing we are going to do is that, okay, let's go ahead and find the coordinates. When x equals to minus 2, what is y from the original equation? So the equation we have there is x raised power, or better still, s cubed minus 12x, okay, plus 5. Okay, that is the function. So go ahead and find f of minus 2. That is plug minus 2 into that function, and we go ahead also and find f of 2, and that should give us the coordinate. So what is f of minus 2? So that is minus 2 raised power 3, minus 2 raised to the power of 3, minus 12 into minus 2, close the bracket, plus 5. That is 21. So the first power of the coordinate, that is minus 2 into 21. 2 into 21 minus 2 and into 21. So this is 21. Okay, so about when x equals to 2, let me just change that minus to plus 2. Change this one to plus, delete, and change this one to plus, delete, equals to minus 11. So that is when it's 2, that is 2 minus 11. So this gives me what? Minus 11. Okay guys, that's the end of the question. X equals to minus 2 and 21, then x equals to 2 and minus 11. Pretty cool, guys. Let's go to the next question. Okay guys, here is the next question. A tangent is drawn to the graph of y equals to x squared plus 3x at the point A. The gradient of this tangent is minus 5. Find the coordinate of point A. Okay guys, do I need to demarcate my board? Yeah, let me go ahead and do that. Let's do it then. Okay, I don't know, let's just do something like this. Okay, so let's get started now. Okay, so the first thing now, we're giving a tangent is drawn to this graph, okay, at point A. So let's just go ahead, because don't forget that tangents will, like, that is the same thing as parallel, but if it has to be normal to a line, so that would be perpendicular. So we use this term in additional maths. Okay, so we now use it in maths. Oh yeah, parallel is tangent, perpendicular is normal, guys, don't forget that. Okay, so now the first thing now is to go ahead and find the gradient of this line. Okay, so to find the gradient, that you differentiate this. Okay, so where can we start? Let's just start from here. So the y dx, find the gradient, or if you like you can just say the gradient. So the y dx is the gradient, so that will give me differentiate it, that is 2x plus 3. Is that clear? Okay, now second, there is something else we need to do here, guys, and this the examiner already told us that the gradient of this tangent is -5. So the gradient is given. Don't forget that the gradient is the same thing as when you differentiate the function, that is the y dx. Okay, from the question, it is what? -5. So we can go ahead and equate this equation to -5. That is the implication. So I can have 2x plus 3 equals to -5, and then collect like time. So okay, so 2x equals to, we'll just take that one to the other end. So -3 minus 5, that is -8. So we have x will give you what? -4. Now, but we have to find the coordinates. Okay, so therefore when x equals to 4, just go ahead and in the original function, what is y? Sorry about that. So therefore go ahead for f of -4. So f of -4, that is in this equation you're going to have -4 squared plus 3 into -4. I need my calculator to complete that. Okay, so that gives me what? So that is -4 square plus 3 into -4, and that gives me 4. Therefore when x equals to -4, y equals to 4. So that is the coordinate of point A. Guys, hope this is pretty cool, guys. Okay, let's go to the next question. Okay, guys, here's the next question. I'll find the equation of the tangent to the graph of y equals to 3x squared minus 5x plus 2 at x equals to -1. Give your answer in the form of y equals to mx plus c. Well, how come this is 7 marks? Okay, so let's go ahead and solve this question. Okay, guys, don't forget that tangent to graph, that is like parallel to graph, but if the question were to be find the question for normal, so that would be perpendicular to the graph. Okay, so now the first thing we are going to do now is to go ahead and find the gradient, the slope. Okay, so let's go ahead and do that. So from y equals to this, what is dy dx? I don't know, should I go ahead and demarcate? I think I'm pretty cool with this. So differentiate the function, and that should give you the gradient. Okay, so when you differentiate this, you have what? 6x minus 5. Okay, now but we are given at what point? At x equals to 1. So when x equals to that gradient at that point, x equals to -1. So just put slash here. You need not to put, just okay. Hey, what is Aluko doing? What's the meaning of this? This is not advanced class. Okay, sorry guys. Okay, just write put put x equals to -1. Guys, this that's why I don't even want to do add math. I don't even like, yeah, this is math. Just put x equals to -1. I hope that is pretty cool, guys. Okay, so let's go ahead and do that now. So what is the gradient now? So the gradient when x equals to 1, divide the x is what? So you are going to have 6 into, I mean, gradient when x equals to -1. Sorry about that. Now when x equals to 1. Okay, before you bite me. Okay, so what do we have here now? So 6 into -1, 6 into -1 plus minus 5. Guys, see, I just need to take my time. I have to use my calculator. I'm not too smart. I can't be saying, oh, you don't even know minus 6 minus 5. Guy, I need to use calculator. I don't know it. Okay, so that's the gradient. Okay, so and that's the gradient of the equation. So now we want to find another equation tangent to this line with this given equation. So generally, how do you write that? So equation of a line parallel or perpendicular to another line is given as y minus y1, okay, equals to m into x minus x1. Okay, now since this is tangent, don't forget that tangent is the same thing as parallel. Therefore, the this one here, let's call this one A. Okay, let's just call this MA. Let's call this one MB of the second line. So MB, since both line are parallel to each other, so therefore we are going to use the same gradients. So I'm going to use this gradient for this MB. Okay, now the next thing is the point. It passes through what point? At s equals 1. So what is y coordinate? So go ahead and find f of minus 1 from the original function. So that should give me 3 into minus 1. I don't know, should I just use my calculator? I don't need to waste my time. 3 into minus 1 square, okay, minus 5 into minus 1, close the bracket, then plus 2. So that gives me what? That gives me 10. That gives me 10. Okay, so this is 10, not minus 10. I don't know, for some reason I'm almost writing minus 10. What is wrong with Aloko? Sorry about that, guys. So now, so passes through what point now? We have minus 1 comma 10. So that is x1 and y1. So you can just label this one x1. Sorry about that. You can label this one x1 and label this one y1. Then go ahead and substitute now. So I have y minus 1 because sorry, minus 10. Sorry about that, guys. So this is y, okay, equals to, and the gradient is minus 11 into x, okay, then have minus 1, so that will be plus 1. I want to make y subject to formula, okay, so because I want to write intercept form in this form. So better still, let's just continue like this. Y minus 10 equals to, let me open up brackets first. So I have minus 11 x minus 11. Hope I'm cool, guys. Okay, then you make y subject of formula then. So that is what? Minus 11x. So move this one there, that will become plus. So that will be minus 1. That is minus 11 plus 10. So what is the final answer? If you don't mind, you can write minus outside into 11x plus 1. That is if you don't mind, but I'm not asking you to do that, guys. Why are you making it difficult again? Okay, just go ahead and write to minus 11x minus 1. So this is equivalent, okay, or equivalent. Okay, guys, that's the end of this question, guys. Let's go to the next question. Okay, guys, here is the next question. Question number 4. Sketch the graph of y equals to x squared minus 3x minus 10. On your sketch, write the coordinates of any turning point and the value where the graph crosses the x and y axis. So, guys, let's just go ahead with the intercepts, x-intercept and y-intercept. Okay, so let me just go ahead and use these boxes as usual, rectangular boxes. Then we'll go ahead and demarcate in order to gain more space. Okay, so let's get started with the x-intercept now. So I'm going to have my x-intercept here. Let me just call it int x-int like integer, okay, and this will give me my y-intercept. So y-intercept. Okay, so I'm sorry about that. Okay, so now let's go ahead now. Now for x-intercept, that is when y equals to 0, and it's also the same thing like the root of the equation. Okay, so when y equals to 0, what are the values of x? Guys, let me just go ahead and do that here now. So I'm going to have something like x squared, okay, minus 3x, okay, minus 10. So I'll go ahead and factorize this. So that will be x okay, x multiplied by x, then this is minus 5 times 2, that should give me minus 10 minus 5 plus 2, that is 3. So I have x minus 5. So if you open up this now, you're going to have that if you expand this, that will give you that expression up there. Okay, but equals to 0, because this is x-intercept is when y equals to 0. So you're going to have something like 0 comma y. What am I talking about? I'm sorry. X-intercept when y equals to 0, that's x comma 0. I'm sorry, guys. I'm just so playful. Okay, so x-intercept, so that is when y equals to 0, and that's what we did here, when y equals to 0. So this one equals to 0, and that's equals to 0. Where y-intercept is when x equals to 0, that is 0 comma y. Okay, so now let's go ahead. This is going to give me x equals to what? X equals to 5, or x equals to minus 2. So the coordinate we have here is we have 0 comma minus 2. That's a point on x-axis, and the second point on x-axis we are going to have I don't know why I put that. I don't know. I'm sorry. I don't know why I put that. That's minus 2 comma 0. Sorry. So because this is x-intercept, so x is minus 2. The first coordinate is for x, and the second one is for y. Minus 2 comma 0. That's on x-axis, and the second one will be 5 comma 0 on x-axis. So let's just go ahead and locate those 2 points first. Minus 2 will be let's just have minus 2 here. So I have minus 2 minus comma 0. That's a boundary point on x-axis. All this look like 2, okay. And let's have a 5 here. So this is 5 comma 0. That's a boundary point here on x-axis too. 5 comma 0. So just label. Okay, yeah, let's go ahead and do the same thing for y. So when x equals to 0, what is y? And from intercept form, so you're going to have y equals to sorry about that, so equals to 0 squared, that is 0, minus 3 into 0, that is minus 0, okay, minus 10. Okay, so then the coordinate we are going to have here for y, we're going to have 0 comma 10 minus 10, better still, sorry about that, 0 comma minus 10. So the y-intercept is 0 comma minus 10. You can see it here also, you can just take it there, so minus 10. So let's just have a minus 10 somewhere around here. So that is 0 comma minus 10. Let me just write it this side here, minus, no, I don't need to put it in bracket, guys. Let me just write minus 10 here, just like the other one. So this is minus 10 here. So the graph is going to cut here. Now the next thing I need to find is my the coordinate of the turning point, and which is a minimum point, and because it's going, let's go ahead and find the minimum point and the minimum value, because this is a positive graph. So to do that, now you have to express this in vertex form or standard form, and to express a quadratic function or equation or expression in vertex form, you just go ahead and use your what? Completing the square. Okay, guys, let's go ahead with our completing the square method. So using completing the square method, I'll be able to get the vertex. That is where the graph is going to originate from. So x squared minus 3x, okay, minus 10 equals 0. So then separate the variable and the constant. So I have x squared minus 3x equals to 10, and then we half of the coefficient of x, so that is x minus 3 over 2. Half of 3 is 3 over 2, okay. Then square it equals what? 10 plus 3 over 2 all square. So what I'm going to do now, just go ahead, I will use my calculator to complete the value on the left hand side, sorry, right hand side, this one here. So I have 10 plus 3 over 2 all square. 3 over 2 square is 3 over 2 square. Okay, so what do I have? Oh, sorry about that. What I press? Oh my, I need to do this again. Sorry about that. Oh, okay. Let's just do that again. 10 plus, let me open bracket for that first so that I don't make mistake again. Then I can put my 3 over 2 here, then square. So that is what? 49 over 4. So I have x minus, okay, I don't know my pod, x minus 3 over 2 all square equals to 49 over 4. Okay, since I'm looking for x, then just go ahead and take square root of both sides. Then I have x minus 3 over 2 equals to minus theta minus 3 over 2. Okay, I don't know why I'm supposed to put like h equals to something like that, but just forget it. H is 3 over 2, and my k, sorry about that, my k is what? My k equals to why did I do this? What am I hiding? What am I playing? Why did I roll for 3 over 4 here? Oh my god, I'm sorry guys. Oh yeah, okay, so this is actually a into x minus h all square minus k. Okay, so k is minus, k is actually plus now because plus k, I don't know, for some reason I'm just k is minus 49 over 4, and it will be like the third or fourth time I'll be using this kind of vertex from every time. Vertex from, what is Aluko doing today? Why is 2020, why is IGCSE just featuring what is vertex from? Don't mind CIE, they just want you guys to then complete the square by force. Okay, so yeah, that's cool. So now I'm going to write this because of so that we know where this point falls. So let me just work in decimal. So 3 over 2, this is actually 3 over 2, that is 1.5. So 1.5 comma, so what is 49 over 4? 49 divided by 4 is what? Is the 12.25. So comma minus 12.25. Okay, so now yeah, the vertex now. So let me just put the vertex here. 1.5 should be somewhere around here. So let's just, this 3 over 2. So let me just put 1.5 here. Then I also need 12.25. Let me put my 12.25 somewhere around here. No, minus 12.25. Minus 12.25. So like you can trace this one down. So this is where the vertex is. So that is the vertex coordinate is what? 1.5 comma minus 12.25. So that's where the graph is going to originate from. Okay, and that's also the coordinate of the what do you call it, the coordinate of the turning point. Okay, and that's the minimum point. So from here now it's going to cut the y-axis on minus 10 and also cut this here minus 2. So your graph can now go up like this. So cut x-axis minus 2 up like that. Don't forget, this is not a point, this is just to determine my vertex. So I'm going to cut here on 5 here, so this also move up here and pass through 5.5 comma 0 and move up like that. So we can go ahead and write the coordinates now. So crosses the x-axis. So x-axis coordinates now I have minus 2 comma 0. Then I also have let's just call that point A. Let's just call this place point A, and let's tag this place point B. Okay, this, I don't know, let's just leave that one. So then point B now will be what? That is 5 comma 0. So more coordinates, that y coordinate now, the intercept here, that is 0 comma minus 10. Can we just tag please C? Let's just target C if you don't mind. Let's just target C. Let's target C. So C, that is 0 comma minus 10. 0, minus 10 because it is y-intercepts. You can see it here, 0, minus 10. Okay, then what other coordinates? Then finally the vertex. The vertex, let me just put it in this form. Okay, 3 over 2, that is 1.5, comma, and what is that? Minus 49 over 4. Minus 49 over 4, and that is 12, minus 12.25. For some reason I do not write 4 and I'm writing something else already. Okay guys, yeah, cool, pretty cool. Yeah, that's the end of this question. Okay guys, let's go to the next question, guys. Okay guys, here is my YouTube channel. Immediately after this section, I'm going to upload the 2020 revised syllabus practice question Cambridge IGCSE 0580. So the solution to that, to all the questions will be uploaded on my YouTube channel, and also you're going to you can also access it via my test shop here. So here is my YouTube channel, guys. There are quite good numbers of math, additional mathematics, ICT, robotic, and coding video that will help you guys enhance your learning. You can see something like database reports, website authoring, how to develop e-learning auto-billing management system using Python programming. Okay, you can see some maths solution question, quadratic inequality, absolute graph, and the factors and polynomials, and differentiation, integration, circle and measure. And you can also develop your own game package using M block or scratch programming. You can see something like Legend of the Fire Lord, and you can develop a quiz using Python programming and create artificial intelligence using Python programming. And most of the maths additional mathematics and ICT videos, they're available on my YouTube channel, actually exam style question, and specifically IGCSE exam style question. So guys, if you find any of my video helpful and useful, go ahead and click like, and you can also comment in order to let me know how I can improve on my video. Okay, and guys, do well to subscribe to my channel, guys. Go ahead and subscribe to my channel. Okay, and also here is my test shop, guys. You can help review any of the resource. If there's anything I can do to improve on my e-learning. Okay, so guys, there are quite good numbers of e-learning and board works and all videos also that are available on my YouTube channel. Also, you can also gain access to all via my test shop. Okay guys, if you find any of my e-learning resources useful, go ahead and help review, and also click like. Okay, and guys, love you guys. Do have a great day ahead. Happy day ahead, and let me say bye guys. Okay, let's end with this note, guys. Let's end with this note.
Wake the streets up.